So, good afternoon, attendees. We will wait for some time for others to join and then we'll start the session. Okay, so now we'll start the session. And I can see very less attendance today, maybe a long weekend and maybe people are busy in their stuff, some holiday plans. So let's start with agentic AI that we are doing. So we'll see first what are the 5 stages of artificial intelligence. So multi-agent systems, right now we are at this. Just take your time to go through this and then we'll go to the next image. And here, sooner or later, we'll reach this level for sure. First, we were into reactive AI, large language models, then agentic AI, task-oriented AI, and then multi-agent systems, autonomous AI teams. Right now, we are here at the center. Then it will be artificial general intelligence. Hopefully, by the end of 2026, we should see it. And if things are perfectly all right by 2028, we should see super intelligence surpass human intelligence, wherein military and wars will be done using AI. If the assumption is correct, artificial intelligence will have its own brain, set of commands, execution of people will be done using super intelligence. And today at 4 o'clock, Nitya ma'am will be joining the session. She will be guiding you to some important topics and points. So she'll be joining at around 4 o'clock. So now, overview of agentic AI. Here we have artificial intelligence, then machine learning, then neural networks, then deep learning, then generative AI, then AI agents, and then agentic AI. And of course, this circle will grow when we have super AI as well. So this is a comparison between large language models, retrieval argument, judgment, AI agents, and agentic AIs. So here you can see the definition and all the other things. Go through it once. And now let's come to the next part, the evolution. From LLM, large language model workflows, to agentic AI. In LLM, what happens? Users will prompt rule-based triggers. In large language models, see data sources and tools and gives you the output. In RAG, user gives the prompt. You have embedding. Your next word is automatically judged based on vector DP retrieval, and then you get data augmented and then output. In AI agents, you give a prompt and then it is connected to database and chat, and it will do all the internal workings, reasoning and tool memory is there. It will give output. In agentic AI, you have memory, reasoning, chat. One agent can talk to another agent and then we get the output. And now this is quite important. How to actually build an AI agent. So here we can see features of traditional AI, generative AI, and agentic AI. So task augmentation was moderate, best for simple rules-based tasks. Generative AI was center context focused, good for drafts but lacks control. Agentic AI is high task automation, uses logic and memory to complete full workflows. Task augmentation minimal, gives you insight but you do the work. Helps create code ideas and context. Generative AI and high. So traditional AI is your data scientist, looks at what happened. Generative AI is your creative assistant, helps you make things, and agentic AI is your digital employee completing complex goals with minimum supervision. So this image shows how RAG works, retrieval augmented generation, RAG. You have a database, then you have embeddings, vectors, then you have vector indexing, indexes, vector database with endpoints. So you have text query, vector embeddings, language models, and search output. So without RAG and with RAG, you can see the difference here for your query. So why do LLMs use token? Because of the flexibility. Tokens handle punctuations, emojis, numbers, and words. Part better understanding. So they break down the words into subwords like unbelievable is broken into un plus believe plus able. It supports multiple languages. Here you can see a US flag and a flag of India and China's flag. So they work for English, Sanskrit, Chinese, and many more. And efficient processing. So tokens become token IDs for fast computation. So if we write a sentence, AI is powerful with an exclamation mark. So tokens break it AI, then is, then power, then full, and an exclamation mark. So they can predict the next word or sentence and understand the emotions as well. So AI agents versus agentic AI. AI agents are built for specific tasks. Agentic AI is a network of multiple AI agents working in collaboration. AI agents operate within a limited scope. Agentic AI handles complex multiple step workflows. AI agents are triggered by prompts or defined goals. Agentic AIs are having a greater autonomy and they can be triggered on the basis of time or some trigger like on chat or on submission of form. So scheduling, email filtering, temperature control, smart automation examples are for AI agents. And for multi-agents, you have collaboration, research assistance, robot coordination, enterprise automation. AI agents do the task, agentic AI coordinates intelligence. So here you can see this is the AI systems layer. So there are different types of AI models you can see here, and there are different usages. You can just go through them. So these are 12 important generative AI concepts. So now, how do we build an AI agent? So these are the steps. This is quite important, so we'll be keeping it for some time. You all can just go through it. If any doubts, you can ask me in the chat. So these are the tools that you should try. So how you can get a effective prompting? So this is the rack chart. So these are DSA concepts. KNN provides exact, highly accurate matches. Whereas ANN sacrifice slight precision. Welcome, Fayaz. How can we fine tune LLM without the confusion? So this article will show everything about that. How SFT reinforcement learning with human interface, LoRa, CLORA, and instructions, how they help. So LLM stands for large language models. It has data, instruction, chats, preferences, learning, SFT, and RLS. HF parameters are full FT, LoRa, and CLORA. What happens after pre-training? An LLM offers pre-training only, knows how to predict text. It does not know. Follow instructions, be helpful, be safe, talk like a chatbot. So we apply fine tuning. Fine tuning is updating a pre-trained model using new data to change its behavior. Fine tuning has two independent layers. Most confusion comes from mixing these three. Fine tuning, learning signals, what data we give, training algorithm, how loss is computed, and parameter update method, how much of the model we change. Why do you train on? This decides the models learn, instruction data, supervised learning, preference learning, chat conversations, domain Q&A, question answers, and human or AI preferences. Learning signals, how the model is trained, training algorithm, how learning happens, supervised learning, preference learning, and parameter update methods, how much the model changes, full fine tuning, LoRa or QLoRa, PEFT. So layer one, this answer, what kind of feedback are we training on? There are only two real ones after pre-training: supervised fine tuning, SFT. You give input, you get correct output. And preference learning, RLHF family. So reinforcement learning with human prompt, answer A, answer B, which one is better? Everything else is built on this two only. What is supervised fine tuning? SFT. Train the model to copy correct answers. Instruction tuning is not new. People say instruction tuning, chat tuning, domain tuning. These are not different techniques. They are just different SFT data sets. Instruction tuning, do X response, user, and legal, medical, finance Q&A, domain training. The model learns what human prefers, not what is correct. So train a reward model from human preference. Use reinforcement learning to push the LLM to get higher reward. This changes helpfulness, tone, safety, politeness, style more than factual knowledge. So there are RLHF style. PPO means classical RLHF algorithm. DPO means simpler preference for optimization. RLAIF AI gives the preference instead of humans. They all use preference data, not labels. So how much of the model changes? So LoRa and QLoRa. So two main approaches: full fine tuning, update all parameters, and PEFT updates only a small subset. So full fine tuning, all model weights are updated. Characteristics, highest flexibility, very expensive, needs a lot of data and GPUs used by big labs. PEFT, parameter efficient fine tuning. Instead of changing all weights, we add small trainable layers. This includes LoRa, QLoRa, adapters, and prefix tuning. Base model stays frozen. So LoRa versus QLoRa. What does LoRa does? LoRa trains small low rank matrices, and QLoRa same, but base model is 4-bit quantized. So QLoRa is much cheaper, almost same quality. So companies go for QLoRa instead of LoRa. So when everything fits, a real LM pipeline looks like pertained expedition, SFT, instruction plus chat data, RLHF or DPO, human or AI preference. So final takeaway, instruction tuning is not a new algorithm. LoRa is not a new learning method. RLHF is not supervised fine tuning. Once you separate data, learning and parameters, the whole fine tuning becomes simpler. Understanding the concepts behind large language models is crucial for any AI interview. So what is large language model? A large language model is a neural network trained on massive amount of text data to understand and generate human-like language. Think of it as a very advanced autocomplete system that predicts the next word based on context. Models like ChatGPT 4 or Cloud have billions of parameters that help them capture patterns in language. They are pre-trained on diverse intertext so they can handle various tasks like writing, summarizing, or answering questions without being specifically programmed for each one. How do transformers work? Transformers are the architecture behind LLMs. Unlike older models that process text sequentially, Transformer uses a mechanism called attention to look at all words in a sentence simultaneously. This lets them understand context before. For example, knowing that bank means a financial institution in one sentence and a river bank in another. The key innovation is that they can process long sequences efficiently and capture relationships between distant words, which is why they are so powerful for language tasks. So, what are tokens in LLMs? Tokens are the basic unit that LLMs work with. They are like chunks of text. A token can be a whole word, part of a word, or even a character. For example, understanding might be split into under, stand, and ing. On average, one token is about 4 characters or 0.75 words in English. This matters because LLMs have token limits. GPT-4 can process around 8,000 tokens to 32,000 tokens depending upon the version. When you pay for API call, you are charged per token used. So here you can see that On average, one token is about 4 characters or 0.75 words in English. So if you have 4 words, it's a token. Simple. And token is the fuel behind the large language models. So yeah, is amazing. So that is 4 tokens. Amaze and ing, there are 2 words. So what are embeddings? Embeddings are numerical representation of words or sentences that capture their meaning. Instead of treating words as random labels, embeddings place similar words closer together in a multi-dimensional space. For instance, king and queen would have similar embeddings because they are related concepts. The numerical formats let the model perform mathematical operations like king minus man plus woman equals to queen. Embeddings are crucial for tasks like semantic search, where you want to find content based on meaning rather than exact keyword match. To explain the attention mechanism, your input processing model receives text sequence, weight assignment, attention, scores calculated for each word, and then context understanding. Model focuses on relevant word for prediction. Attention is how the model decides which words to focus on when processing text. When reading, the cat sat on the mat because it was tired. The model uses attention to understand that it refers to cat, not mat. It assigns higher attention scores to relevant words. Self attention lets the model weight the importance of every word relative to every other word in the sequence, which is why transformers are so good at understanding context. What is context window? So attendance link is shared. We'll have a 5 minutes break here for attendance, and then, of course, yesterday there was no class, Surekha ma'am. Please fill up the attendance. We have 5 minutes. So I guess there is a question asked by Farhana ma'am. Yeah, I guess, yeah. Fatima. But if we are using platforms like NA10 or Make that we used on Wednesday, and again, hopefully we'll be using on Monday. So there we can make AI agents of our own. But we need some theory also for that. And today you can see the number of attendees. There are hardly 70 present. One is me, one is Sushmita ma'am. So technically speaking, there are only 69 attendees. Or else we have more than 100 or maybe 150 plus. So today's session will be more of the theory because practical, it's not fruitful for everyone. It's there already in the chat, sir. So we give an input, user instruction and examples, token size, output. So prompt engineering, crafting effective prompts is an essential skill for working with LLMs. This section covers techniques like zero, short, and few short learning, prompt parameters, and how to handle common issues like hallucinations. Hallucination is a human term that is used with machines wherein they give results that are not accurate or precise. For example, if I tell how is the weather of Pune and where is Pune, so it says that Pune is a very hot city in Arizona, USA. And there is nothing like a place called Pune in Arizona. So that is called hallucination. So what is zero shot prompting? Zero shot prompting is when you ask the model to perform a task without providing any examples. You describe what you want in plain language. For instance, translate this to French hello or summarize this article. The model relies entirely on its pre-training to understand and execute the task. This works well for common tasks the model has seen during training but might struggle with very specific or unusual requests where examples would help guide the output format. Classify this email as urgent or not email text. Now, what will the model do here? So now, what is few shot prompting? Few shot prompting means giving the model a few examples before asking it to perform the task. You are essentially teaching it the pattern you want. For example, if you want a specific JSON output format, you would show 2 to 3 input output examples first, then provide your actual input. This dramatically improves accuracy for structured output, specific tones, or unusual tasks. The model learns from the examples and applies that pattern to your new request. It's like showing someone how to solve a math problem before asking them to solve a new one. So the pattern is recognized and it learns through training. Okay. So what are system prompts? Role definition. Set the AI's persona at expertise level, behavior guidelines, define tone, style, and responsive format, constraints, specify what to avoid or emphasize. So when we did system prompt, we already did it. So system prompts are initial instructions that set the overall behavior and personality of the AI. They are like giving the model a job description before it starts responding. For example, you are a helpful Python tutor who explains concepts simply, or you are a formal business writer. System prompts persist across the entire conversation, while user prompts are individual messages. They are crucial for building consistent chatbots or AI assistant with specific personalities or expertise area. So now this is the important thing. What is temperature in LLMs? Temperature controls how random or creative the model outputs are. It's a number typically between 0 and 2. At temperature 0, the model always picks the most likely next word, giving you deterministic, predictable outputs. A higher temperature like 1.5, it considers like less likely options, making responses more creative but potentially less coherent. For factual tasks like data extraction, use low temperatures between 0.1 to 0.3. For creative writing or brainstorming, use higher temperatures between 0.7 to 1.2. It's one of the most important parameters to tune for your specific use. So what is top P nucleus sampling? So temperature versus top P. Temperature adjusts randomness globally. Top P filters the word choices considered. Top P is another way to control randomness by limiting which words the model considers. Instead of looking at all possible next words, top P only considers the smallest set of words whose cumulative probability exceeds P. For example, with top P equals to 0.9, the model only picks from the top 90% most likely used words. This gives you creative outputs while avoiding very unlikely words that might be nonsensical. It often used together with temperature. You might set temperature to 0.8 and entropy to 0.95 for balanced creative responses. So what is hallucination in LLMs? Hallucination is when an LLM generates information that sounds confident and plausible, but it's completely made up or factually wrong. For instance, it might cite research papers that don't exist or provide incorrect dates for historical events. This happens because LLMs are trained to predict plausible text, not to verify truth. They don't have a built-in fact-checking mechanism. To reduce hallucination, you must use techniques like providing source documentation RAG, asking the model to cite sources, using lower temperature settings, or implementing verification steps where you check outputs against reliable databases. So, to avoid hallucination, RAG is the best choice. Like you support your answer with some sort of documentation. So, what is RAG? Retrieval augmented generation. Again, repeating it, retrieval augmented generation. RAG is a powerful technique that combines LLMs with external knowledge base. Instead of relying solely on the model training data, RAG it retrieves relevant information first, then generates response based on that retrieved context. Why do we need RAG? Up-to-date information LLMs have knowledge cutoff date. RAG provides current data, private data access, query internal documents without retraining the model, reduce hallucination. grounding responses in actual retrieved document improves accuracy, and source attribution can cite specific documentations used in generating the answer. RAG solves the problem of LLMs being stuck with outdated training data and making up facts. Instead of fine tuning a model on your data, you keep documents in searchable databases and retrieve relevant chunks when needed. So how does RAG works? You put a user query, it searches for vector database embeddings and then go to external documents. What is chunking in RAG? Chunking is splitting long documents into smaller pieces before storing them in vector database. You can't store an entire 100-page document as one embedding. It takes too much information. Instead, you break it into chunks of 200 to 50 tokens, roughly 1 to 2 paragraphs. The challenge is choose chunking size and overlap. Too small, you lose the content. Too large and retrieval becomes less precise. Many systems use overlapping chunks. For example, chunk 1 is paragraph 1 to 3 chunk. Chunk 2 is paragraphs 2 to 4. So important information appearing at chunking boundary isn't lost. So you do repetitive tasks. So what is vector database? A vector database stores embeddings, numerical representation of text and enables fast similarity stretches. Unlike traditional databases that search for exact matches, vector database finds items that are semantically similar. Popular options include Pinecone, Vivatine, and ChromaDB. When you query what's your refund policy, it doesn't need to contain those exact words. It finds document about refund returns and money back guarantees because their embeddings are similar in vector space. This semantic search is more powerful than keyword matching. So you have Pinecone managed, Rewrite, open source, ChromaDB lightweight, Fez is by Facebook. So what is semantic search? Semantic search finds results based on meaning rather than exact keyword. Traditional search looks for documents containing your search term, semantic search understands that auto and car means the same thing, or that how do I reset my password and forgot login credentials are about the same topic. It converts both the query and documents into embeddings, then find documents with the closest embedding vectors. This is far more powerful for Q&A system because you user really phrase questions using the exact words in your documentation. So instead of training the user, obviously we will train the database. So now how are embeddings used in RAGs, document processing, storage, query embedding, similarity search, context injection. So fine tuning, you prompt and you do fine tuning. So fine tuning versus prompting. Choosing between fine tuning and prompt engineering is a critical decision. Each approach has different costs, data requirements, and use cases. Understanding when to use one can save significant time and resources. So this is the last thing when you should use prompting instead. Using prompting when need quick deployment, have limited training data, task changes frequently, budget is a constraint. So prompting is better when you need flexibility, have limited data, or want to iterate quickly. It costs nothing beyond API calls and require no training data preparation. Modern LLMs are so capable that good prompting engineering will, with technique like few short learning and RAG can achieve excellent results without fine tuning. It's the right choice for most applications, chatbots, documentations, Q&A, summarization, classification. Only move to fine tuning if prompting doesn't meet your quality requirements after optimization. So here we come to the end of this session. Anyone any doubts? So we are almost done for the day. Ma'am, can we end the session?
Yeah, yes, sir. We can wind up.
Sure. Thank you, everyone.
Thank you, sir. Yeah, so as informed, sir, we are conducting a day 5 session on Monday at 3 p.m.
Sure.
Thank you, sir.
Thank you, everyone. Bye-bye.
Yeah, so dear faculty members, as informed by last session, we are conducting a day 5 session on Monday at 3 p.m. I request please inform your colleagues or friends to join the session on Monday as well. So both the certificate and all, I'll update you on Monday. So I request please join the session on Monday. Okay, thank you all. Thank you for joining.